Hi, good morning. This is Raj Yadav from Institute of Aeronautical Engineering, Hyderabad. My branch is AML, allied to CSC. This is the concept video that I am recording. The subject of computer organization and architecture. And my topic name is Booth multiplication algorithm is my topic. This is presented by the Raj Yadav. First of all, what is the Booth multiplication algorithm? Booth multiplication algorithm. Booth algorithm is a multiplication algorithm that allows us to multiply two times binary integers in two's complement respectively. It is also used to speed up the performance of the multiplication process. It is very efficient. It works on the string with zeros in the multiplier that requires no additional bit. Only shift the rightmost string bit of one in a multiplier bit weight 2k to weight 2m that can be considered as 2 power k plus 1 minus 2 power m. This is the structure of the Booth multiplication algorithm. The process starts from the start, and AC and Qn plus 1 C are the resistors, and the BR and multiplicand and QR multiplicand, and Qn and QR are the processors. AC, it has two wings. AC left side is the AC plus B bar, BR bar plus 1, and the right side is 0, 1, that equals to AC plus BR, and ASHR AC plus QR, SC equals to sequence counter and the SC minus 1, and at the end it ends the process. In the above flowchart, initially AC and Q n plus 1 bits to set the 0 and are to set to 0, and SC is a sequence counter that represents the total bits set n, which is sequential to the number of bits in multiplier. There are BR that represents the multiplicand bit, and QR represents the multiplier bit. After that, we encounter that two bits of multiplier as Qn and Qn plus 1, where Qn represents the last bit of QR and Qn plus 1 represents the incremented by bit of Qn by 1. Suppose the 2 bits of the multiplier is equal to 0, equals to 10. It means 1, 0 means that we have to subtract multiplier from the partial product in the accumulator AC. Then perform the arithmetic shift operation ASHR if 2 of the multipliers equals to 0, 1. It means we need to perform the addition operation, the multiplicand to the partial product in accumulator AC, and then perform the arithmetic shift operation including Q n plus 1. Arithmetic shift operation is used in Booth's algorithm to shift AC and QR bits to the right by 1 and remains the sign bit in AC unchanged, and the sequence counter is continuously decremented till the computational loop is repeated equal to the number of bits n. Finally, the working of the Booth algorithm. First of all, set the multiplicand and multiplier binary bits as M and Q respectively. Initially, we set AC and Qn plus 1 register values to 0. SC represents the number of multiplier bits, Q and sequence counter that is continuously decremented till equal to the number of bits n or reach to 0. A Qn represents the last bit of Q, and the Qn plus 1 represents the incremented bit of Qn by 1. On this step is the on each cycle of Booth algorithm, Un and Qn plus 1, which will be checked on the following parameters as follows. When bits Qn and Qn plus 1 are 0, 0 or 1, 1, we simply perform arithmetic shift right operation to the partial product AC, and the bits of Qn and Qn plus 1 is incremented by 1 bit. If the bits of the Qn and Qn plus 1 shows to 0, 1, and the multiplicand bit M will be added to the AC. After that, we perform the right shift operation to the AC and QR bits by 1. If the bits of the Qn and Qn plus 1 is shows to 1, 0, the multiplicand bit M will be subtracted from the AC accumulator register. After that, we perform right shift operation to the AC and QR bits by 1. These are the steps which are followed in the fifth step. And the next one is the operation continuously works until we reach 1 bit in the Booth algorithm. Result of the multiplicand binary bit will be the stored in the EC and QR registers. There are two methods used in the Booth algorithm: right shift circular method, and it shifts the rightmost bit of the binary number and then it added to the beginning of the binary bit. And in the picture 1, 0, 1, 1, 0, after the automatic right shift operation by 1, add the first bit to the last one, then 0, 1, 0, double 1. This is how it should be done. And the second method is right shift arithmetic method. It adds two binary numbers and binary number bits, then shift the result to the right by 1 bit position. Example, if 1, 0, 0, 1, 1, 0, 0 plus 0, 1, 1, 0 less than or equals to or greater than or equals to 1, 0, 1, 0. After adding the binary number, shift each bit by 1 to right, put the first bit of the resultant to the beginning of the new bit. This is the example of two numbers of Booth multiplication algorithm, 7 and 3. This is the process. This is the values how we initialize and continue with the process until the Booth multiplication as single digit. This is the working principle of and working of the Booth algorithm. Set the multiplicand and multiplier binary bits as M and Q respectively. Initially, we set AC and Qn plus 1 register value to 0. C represents the multiplier bit Q and the sequence counter that is continuously decremented till equals to the number of bits are reached to the 0. The Qn represents the last bit of the Q, and Qn plus 1 shows the incremented bit of Qn by 1. And on each cycle of Booth's algorithm, Qn and Qn plus 1 bits will be checked on the following parameters as follows. First one, when the two bits Qn and Qn plus 1 are 0, 0 or 1, 1, we simply perform the arithmetic shift operation to the partial product AC, and the bits of Qn and Qn plus 1 is incremented by 1 bit. If the bits of Qn and Qn plus 1 is shows to 0, 1, multiplicand bit M will be added to the AC. After that, we perform right shift operation to the AC and QR bits by 1. If the bits of Qn and Qn plus 1 shows 1, 0, then multiplicand bit M will be subtracted from AC. After that, we should perform the right shift operation to the AC and QR bits by 1. And the next one is the operation continuously works till we reach n minus 1 bit in Booth's algorithm. Result of the multiplication binary bit will be stored in the QC and QR register, AC and QR register. There are two methods used in the Booth algorithm. First one is the right shift circular method. It shifts the rightmost bit of the binary number, then it's added to the beginning of the binary number. This is the first method which is used in the Booth multiplication algorithm. And the second one is the right shift arithmetic. And first one is the right shift circular, and second one is the first shift arithmetic. It adds the two binary bits, then shifts the result to the right by 1 bit position. Example, if 0, 1, 0, 0 plus 0, 1, 1, 0 is greater than or equal to 1, 0, 1, 0. After adding the binary number, we shift each bit by 1 to the right and put the first bit of resultant to the beginning of the new bit. This is the second method of Booth multiplication algorithm. And this is the example of the two numbers 7 and 3 initialize and subtract the value and the right shift operation, adding, right shift operation, right shift operation. This is the process how we use and Booth multiplication algorithm in the computer architecture and organization. It is mostly used better to perform the additions and multiplication of Booth multiplication is a multiplication algorithm that allows to multiply two signed binary integers in two complements respectively. It is also used to speed up the performance of the multiplication process. It is very efficient to work on strings. Thank you.